So good day to you all. Dear students, we have come into the module 2 of our embedded systems, and in this module we are going to discuss about the instruction set and programming of ARM microcontroller, in particular the ARM Cortex M3 type of microcontroller. So the topics we are going to discuss in this module are the assembly basics, that shows what are all the various assembly level instructions. Already I discussed the assembly level instructions means what are all the mnemonics or opcodes. And the second thing is what are all the special instructions that is exclusively available for the ARM processors. And we can also program the ARM processors using the C programming, and they have a specific extension for this C programming, and that comes under this CMSys. So this is actually the Cortex M model for software interface. So we are going to discuss the CMSys also in this particular model. We will get into the model 2. First we will start with what is an assembler, why I have to go for an assembly level language. Right, generally we know the assembly level language is mostly used in all the microcontrollers or microprocessors. Why? Because whenever we design a microprocessor or microcontroller, this assembly level language is actually tailored or customized according to the architecture. So that gives the basic information about what is the size of the data that we are going to use. Say for example, when we are going to use C, then the data types are already fixed. What is the size of word, what is the size of byte, so everything is already fixed. But here, according to the architecture of the microcontroller, we can define the size. Either the data operated is 8-bit or it is a 16-bit or it's a 32-bit. So in our case, our microcontroller is 32-bit, but when we use that assembly level language, depending upon the size of the microcontroller what we use, we can have specific or customized opcodes that are available. So the first advantage of using this assembly level language is it is customized or tailor-made according to that microcontroller. That is actually the first thing. The second thing is, again, it is a better efficiency. So what is the memory size that is available, right? Normally when we compare the microcontroller memory, which is going to be comparably lower than the microprocessor, because in the microprocessor we will be adding some extra memory chips. But here again we can add it, but the available memory, that inbuilt or on-chip memory we can say, will be very minimum. So we have to efficiently use the memory. So in that case, the program should not consume so much of memory. So already we discussed the thumb instruction is actually of 16-bit size instead of 32-bit ARM instructions, right? So that we can pack more number of code, that is the code density is higher in the case of ARM microcontroller. So in such a way that here we can have a better efficiency, right, in programming as well as code development. The third thing is evaluation of high level language is easy. Say for example, when we are going to write a program in C language, right, so we are going to convert it into high level language, and when we want to debug it, right, where some problems are wrong, so in that case what we can do is the equivalent assembly level language program will be easy for debugging, because using this assembly level language program we can find out how the register data changes, how the system executes the program, and how dynamically the values of various registers or various memory points are changing, so that we can easily find out where my problem is and how I can rectify the problem. So these are all some of the advantages why we have to go for assembly level language program. So that's why we are actually using this assembly level language programming. We will start with the assembly basics now. The general syntax of an assembly level language program, or the mnemonics we can say, or opcode, whatever it is, based programs will be something like this. So initially we will be having a label. Most probably the label will be optional, so that whenever we want to have a conditional transfer or unconditional transfer of the control, then we have to make use of this label. Otherwise the label is an optional one. Then we will be having the opcode. Again it is called as a mnemonic, whatever it is, that is actually the instruction. And after that instruction, the operands will be followed, right? So there may be 2 or 3, whatever may be the operand, 1 or 2 operand may be there, depending upon the instruction. And finally, anything after a semicolon will be treated as a comment, right? Again, the semicolon is not compulsory like C, but anything above after a semicolon will be treated as a comment. So these are all some basic structure of a assembly level language program. So again, you will see the one by one. The first thing is label is optional, right? The second thing is the first operand is the destination of the operation normally. So in most of the cases, the first operand will be the destination. Say for example, in the above case, we start with the operand 1, right? So whatever may be the operation that is performed, the result will be stored in the operand 1. So that is going to be the destination of the operation. Then generally we have so many types of addressing, and one type of addressing is immediate addressing, where we are going to provide a data in the instruction itself. So that immediate type of addressing is mentioned as hash number, right? So the data is straight away available in the instruction. That is actually immediate type of addressing. Of course, we are going to discuss that a bit later. The text after the semicolon is a comment, of course, and we can define the constant using a few things, and one such command is called equivalent. One such command is called equivalent, right? So here actually on the right hand side you can see a small segment here, right? You can see a small segment where you can see that LDR is available, R0 is available equal to NVIC. So some instructions are there, right? So that instruction data which is equal to NVIC, that value will be moved on to the destination register, that is called R0, right? Already we have discussed what all the registers available, what are the general purpose registers and what are the special purpose registers. So the data can be transferred from memory to register as well as register to memory, or one register to some other register. So all these things are actually possible here. Now this small program segment explains what is the use of EQU. So the first line you can see here, NVIC IRQ SCT ENT, right? So this is actually a variable name, right? Don't bother, you can just take it as an A, no problem. So the first line is A equal to 0xE000E100. So this hexadecimal number 0xE000E100 will be assigned to the variable A, assuming I am placing a A there, right? Again in the second line what you can see, there is an NVIC, then there is an IRQ enable equal to 0x1. So this 0x1, again the hexadecimal number will be assigned to that particular variable, and this variable, instead of that number, this variable can be used in the program. So this small program segment uses how to use the instruction EQU, right? That can be done. And again on the top you can see there are two things are available, two move statements are available. Of course this gives an idea about how a instruction will look like, right? Say for example the first instruction is move R0, hash 0x12. So in that case R0 is a general purpose register, already we know that, and hash symbol says it's an immediate addressing, so the data is straight away available there. So the 0x12 will be moved to R0. So R0 equal to 0x12. That is actually the first meaning. The second instruction is move R1, hash A. So since the hash is available, again it's immediate addressing. So the ASCII character capital A will be moved to the register R1. So this is how the data transfer using this immediate addressing is done. So these are all a few examples for that. Then there are plenty of types of instructions are available, even though this is actually a reduced instruction set computer, a RISC processor. There are so many instructions are available because there are various instructions like classicom instructions are there, then thumb instructions are there, thumb2 instructions are there. Though we are going to use only thumb2 instructions, since the system is a complex one, right? Say for example it is capable of doing more functions, the number of instructions also keeps on increasing, right? So the first thing is the types of instruction we can see, or we can classify the total number of instructions available according to these categories. We can say the first thing is a 16-bit data processing instruction. So what is meant by data processing means data manipulation, like any data change, that may be an addition, subtraction, multiplication, division, then doing some logical operations, whatever it is, right? So this is actually again shifting and rotating, everything comes under this data processing instructions, right? Then the 16-bit and 32-bit branch instructions. I want to transfer the control from one location to the other location in my program, right? Say for example one address to some other address. So something like if then, right? You will be writing go to or something like that in your C code. In a similar way we can control we can transfer the control from one location to some other location, and for that purpose we are going to use the branch instruction. Again there are 16-bit as well as 32-bit branch instructions are available. Then the 16-bit load and store instructions. So what does it mean actually? We are going to access the memory, right? I want to store some data which is available in the register into the memory. That is called storing of data. And some data is available in the memory. I want to read it into my register. That is called loading. So 16-bit load and store instructions, that is accessing the memory, is possible. Then there are other 16 and 32-bit instructions. Of course, we will give the list and explain what is them in the forthcoming slides. In a similar way, we can also process 32-bit data processing instructions. So that is what actually the advantage of this, right? So we can separately process. Supposing if the data size is only 16-bit, right, in some cases. So we need not waste another 16-bit with the zeros because it's going to be only 16-bit. So instead of using a 32-bit, we can limit the data size to 16-bit so that you can pack more data and more code using the ARM processor. That is actually the advantage. And supposing if the system needs a 32-bit memory access, then there is specific 32-bit load and store instructions are also available. And then memory access, multiple memory access, pre-indexing and post-index memory access are possible. Again, as I said, the memory need to be processed, especially when you are going to use some sort of tables, right, or you are going to use an array of elements. So in those cases, the memory need to be accessed. And based on this memory access, we have two types of indexing is possible. One is called pre-indexing and post-indexing. Of course, we are going to see them. Then again, pure arithmetic instructions like the add, subtract, then add with carry, subtract with borrow, all those instructions are there coming under this arithmetic instructions. Then logical operators, shift, rotate operations are again possible. Logical means AND gate, OR gate, XOR gate, something like that, right? And sign extension, data reversing and bit field manipulation. So again, the sign extension is we have to retain the sign of the data